Introduction to James Webb's latest image. One of the leading and most respected physicists of today has recently shared his thoughts on a groundbreaking discovery. Michio Kaku, widely known for his exceptional contributions to the world of physics, has confirmed that the James Webb Space Telescope has made an astonishing find: 6 enormous galaxies that were previously believed to be impossible. This discovery holds the potential to significantly expand our understanding of the universe, making it an exciting development to monitor closely. Kaku, a renowned figure in the scientific community, is of both American and Japanese descent and is an expert in classical experimental physics and quantum mechanics. Unlike more cautious scientists who are skeptical, Kaku is open to the extraordinary findings of the James Webb Space Telescope. His willingness to embrace these findings brings a refreshing perspective to the conversation, and we're thrilled that such an accomplished scientist has chosen to speak out, sharing what is now undeniable. The enthusiasm and even amusement in Kaku's tone are evident as he talks about the discoveries made by the James Webb Space Telescope. He views it as a recent event that has sparked his deep interest in the field. Join us as we delve into the implications of Kaku's view on the significance of these 6 enormous galaxies. First impressions of the telescope. Michio Kaku has been a scientist all his life. He is open to exploring new theories and ideas, recognizing that Einstein's theory of relativity and Newton's laws cannot fully explain the complexities of the universe by themselves. Kaku believes that the findings of the new telescope have the potential to significantly enhance our scientific understanding, even though many of his peers are still unwilling to accept this perspective. This hesitation has prompted concerns and debates among proponents and critics of the Big Bang theory, as well as those who support or oppose quantum mechanics. Despite these reactions, Kaku remains unfazed, often finding humor in the skepticism surrounding the new discoveries. The James Webb Space Telescope's revelation of 6 enormous galaxies, dating back to the universe's earliest moments, has caught astronomers off guard. These galaxies contain significantly more stars than the Milky Way, despite having formed only 700 million years after the Big Bang. The group of astronomers who made this groundbreaking discovery has coined the term universe breakers for these exceptional galaxies, as their existence could significantly alter our entire comprehension of the cosmos. Challenging the Big Bang theory. The new findings challenge the established understanding of the Big Bang theory, which suggests that immediately after the initial explosion, the universe was in a chaotic and hot state, with the first solid structures taking hundreds of thousands of years to form. It was previously assumed that galaxies, as highly organized structures, formed much later. However, some of the newly discovered galaxies are more massive than the Milky Way, and their immense brightness suggests they were rapidly forming stars, perhaps hundreds annually. In contrast, our galaxy forms stars more sporadically. The exact time when the first galaxies emerged remains unclear. So far, research has been unable to determine this, but it is widely believed that, initially, only small groups of stars or individual stars existed, gradually merging to form larger and larger structures, eventually becoming small galaxies. Over time, these smaller galaxies collided with others, growing in size. According to previous models, such large and complex galaxies could not have existed so early in the universe's history. This brings up the intriguing possibility that the universe may be much older than previously thought, or that complex galactic formations developed much earlier than anticipated. However, this theory remains difficult for more traditional scientists to accept, and some factions within physics strongly reject this discovery, as it calls into question the accuracy of age estimates. Kaku, fully aware of these challenges, remarked that numerous inaccurate and outdated theories persist due to the prestige of certain scientists. These outdated models were only discredited once their flaws were exposed by experiments. Therefore, the foundation of science, particularly in the field of physics, is held by experimentalists, who hold theorists accountable when it comes to understanding the true beginnings of the cosmos. Humanity's limited knowledge of the universe. Humanity knows very little about the Big Bang theory and the evolving understanding of the universe. The Big Bang theory was proposed in 1927, based on observations of the expanding universe. According to these observations, the universe originated from a singular point and has been expanding ever since. At that time, The concept of a universe with a beginning and an end was nearly impossible for people to grasp, as the idea of a universe that had always existed seemed inconceivable. Even today, scientists continue to struggle with fully understanding the universe's true nature. However, the latest discoveries, while seemingly contradicting the Big Bang theory, should be considered with an open mind. Science has shown repeatedly that progress often comes from re-evaluating old ideas. The confirmation of brand new hypotheses and discoveries is an essential part of the scientific process. For instance, when people once believed that planets and stars were stationary, occupying fixed positions in the cosmos, later observations proved otherwise. We now know that planets move, stars orbit within galaxies, and entire galaxies are soaring through space at incredible speeds, their ultimate fate still uncertain. Today's scientists face the difficulty of accepting unpleasant truths, realizing that theories are not absolute and must undergo stringent examinations before they can be considered valid. How this changes our perspective on the universe. The Big Bang theory emerged from the observation that galaxies are moving away from each other, with a speed of separation proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe had been expanding for quite some time. Further supporting evidence came from elements such as cosmic background radiation and the redshift of distant galaxies. However, it is crucial to keep in mind that people in the past held incorrect beliefs, such as the idea that the Earth was flat or that the Sun revolved around us. These beliefs were backed up by the evidence available at the time, but only later did technological advancements provide a clearer and more accurate view, proving those presumptions false. We are now in a similar situation, where the expectations surrounding the James Webb Space Telescope have not confirmed the Big Bang, but instead have revealed 6 galaxies that appeared unimaginable. This development serves as a reminder that science is in constant change, and researchers must remain open to fresh findings that challenge existing theories. Redshift and its role. Redshift, a tool used by researchers to measure quantities in cosmology, provides insights into the motion of celestial objects and helps determine the expansion rate of the universe. Celestial bodies refer to the change in the wavelength of light as the source of the light moves relative to the observer. For example, when a car approaches, the sound of its engine becomes more audible, but as it moves away, the sound fades. The same principle applies to light. When a light source moves toward an observer, the light shifts toward the blue end of the spectrum. As it moves away, the light shifts toward the red. This phenomenon, known as redshift, has been used to calculate the velocities and distances of celestial objects. However, small errors in these measurements could significantly influence outcomes, resulting in a re-evaluation of measurement techniques. The revised data remain to be seen and will reveal whether recent discoveries related to our universe necessitate a thorough examination to determine whether errors in redshift measurements are responsible, or if there is another explanation. Simply put, scientists are refusing to recognize that this is an important question that requires careful analysis, a review of the methods, and expert opinions on the data. As we continue to explore the depths of the universe, it's clear that the scientific landscape is shifting. The discovery of 6 massive galaxies challenges long-held assumptions about the universe's timeline and formation. Conventional cosmology, with its emphasis on the Big Bang theory, has been the dominant method for comprehending the genesis of the universe. The idea that such large galaxies could have formed so soon after the Big Bang upends the established story and beckons us to consider numerous aspects of cosmic evolution. For years, researchers have worked within the framework that the universe was in a hot and chaotic state after the Big Bang. Over time, it cooled sufficiently for the first atoms to form and for structures to take shape. The dominant theory suggested that highly structured and massive galaxies could not have appeared early in the universe's history. However, the discovery of these galaxies challenges this assumption, posing a major question. Could the universe be older than previously thought? Or perhaps complex structures like galaxy formation began much earlier? This new revelation is not just a curiosity. It could have profound repercussions for our comprehension of everything from the basic rules of physics to the structure of the universe. Some scientists argue that the speed and size at which these galaxies form challenge current models of galaxy evolution. Our current understanding suggests that galaxies formed over billions of years, gradually coalescing from smaller groups of stars and gas. The concept that such vast luminous galaxies could have formed in the first 150 million years after the Big Bang is perplexing. This revelation raises a potential paradox. How could such large and well-organized galaxies form so quickly in a universe that, according to the Big Bang theory, should have been in a significantly less stable and ordered state? While many researchers remain cautious regarding this discovery, others embrace it as an opportunity to reconsider long-standing assumptions. Michio Kaku himself has emphasized that science is an evolving field where new discoveries can challenge and even overturn previous theories. He noted that many ideas once thought unquestionable were eventually proven wrong. For instance, the theory of a geocentric universe was widely accepted for centuries before being replaced by the heliocentric model. Similarly, the discovery of these 6 galaxies by the James Webb Space Telescope may eventually result in a significant shift in our comprehension of the universe's beginnings. Kaku emphasizes the importance of embracing new ideas, remaining open to revising old theories, and recognizing the significance of experimentation. Science, particularly in physics, relies heavily on the work of experimentalists to keep theoretical science grounded in reality. New findings like the discovery of these galaxies challenge existing models, prompting scientists to reconsider their assumptions and adjust their theories accordingly. While some may resist this fundamental shift, Kaku's optimism and adaptability serve as a reminder of the dynamic nature of scientific progress. He inspires others in the field to keep an open mind and a sense of wonder, understanding that scientific investigation is motivated by a willingness to explore the unknown. Just as we once believed that stars and planets were fixed in place, today we understand that everything in the universe is in motion. The same principle applies to our understanding of the cosmos. Our theories must be flexible, adapting as new data emerge. As we continue to explore the universe with advanced technologies like the James Webb Space Telescope, it's crucial to remain humble and aware of the limitations of our knowledge. The discovery of these 6 massive galaxies is only the beginning of a new chapter in cosmology. It will likely motivate additional research and experimentation, and we may one day look back at this moment as a pivotal turning point in our understanding of the universe's past. The application of redshift as a tool for determining cosmic distances and velocities is one example of how scientists gather data to test their theories. By observing how light shifts in response to the motion of objects in space, astronomers can calculate the distances of these objects and how fast they are moving. This technique has greatly aided our understanding of the universe's expansion. However, as we have seen, it is not without its challenges. Small measurement errors can have significant consequences, and as technology improves, new methods for measuring and analyzing cosmic data may emerge. Given the complexities of the universe and the limitations of our current technology, it is necessary to maintain an open mind and be willing to re-evaluate established theories. The discovery of these 6 galaxies has raised more questions than answers, but it also presents an exciting opportunity to explore the cosmos in new ways. Scientists must continue refining their methods, testing their theories, and remaining receptive to the possibility that the universe may be even more mysterious and intricate than we currently understand. As we look ahead, it's clear that we are on the cusp of a new era in cosmology. The James Webb Space Telescope has already delivered groundbreaking results, and the discoveries it continues to make will likely reshape our understanding of the cosmos. The universe is full of surprises, and as new information comes to light, our knowledge will continue to evolve. Just as past scientists had to let go of outdated beliefs, today's researchers must be willing to embrace new ideas and challenge the status quo. The discovery of these 6 massive galaxies serves as a reminder that science is a journey, not a destination. It requires curiosity, open-mindedness, and the courage to question even the most widely accepted theories. As we continue to explore the universe, we can only hope that the discoveries made by the James Webb Space Telescope will unlock even more cosmic mysteries and lead to deeper insights into the origins and evolution of the universe. As we stand on the brink of these revolutionary revelations, the potential for redefining our place in the vast expanse of space is greater than ever before. The discovery of 6 massive galaxies challenges preconceived notions. While skepticism remains in certain quarters, the fact that they exist and are being examined more closely signals witnessing the dawn of a brand new era of cosmology, one where the boundaries of the past are pushed and new concepts emerge. In the coming years, scientists will undoubtedly continue discussing, analyzing, and re-evaluating these discoveries. One thing is certain: the exploration of space is far from over. The James Webb Space Telescope's discoveries offer a fresh perspective, urging scientists to cast aside old beliefs and embrace a future where anything is possible. As additional data are gathered, we will see if these galaxies provide clues to a deeper understanding of cosmic evolution, potentially changing everything we thought we knew about galaxy formation and the Big Bang. As Michio Kaku pointed out, scientific progress thrives when existing obstacles are questioned. The information and discoveries gleaned from the James Webb Space Telescope encourage us to consider alternatives to traditional models and challenge everything we think we know about physics, cosmology, and astronomy. The field is ever evolving, and future breakthroughs will play a crucial role in shaping our understanding of the universe. For those following these developments, it's an exciting time to be part of the scientific community. We are on the cusp of unraveling mysteries that were once thought unimaginable, and the future looks incredibly bright. As we continue to explore the universe with extraordinary technology, stay tuned. There are solutions waiting to be discovered.